Okay. The second important networking component called 2.2 servers. Okay. So which is used to host any web applications or SMTP services or anything. Even it could be any FTP file service, whatever. Okay. We are used to host any for the web applications. The third one is 2.3 network interface card. Okay. So this is one of the most important to connect to the computers and servers to a network. Okay. This interface will play a very important role. So as you are the freshers, okay, or if you have the 1 or 2, 3 years experience, so when we have the network issues, you may a couple of users from the network or from the compute team or from the web application team, they might reach out to you stating all of a sudden the application completely goes down. Okay, they are unable to access the web application. Okay, so at the time, the first step you have to verify is as a physical engineer or a cable engineer. Okay, you have to check whether this interface is up and down. There are a lot of scenarios in the data centers. Okay, because of this network interface down. Okay, because of the network interface down, the application will goes down. But no one will check the interface, and instead of that, they will cross verify the application debox network analyze by using the Wireshark. They will do a lot of things. But at the end of the day, the issue could be with the interface itself. So as a network engineer, you guys has to always remember, go for from the basic, very first steps onwards. Try to verify to this, try to log into the switch and check the interface is up and down. Okay. So this is the most important networking component to connect. This is to connect our computers or servers. On computers and servers to a network. Okay. The next important component is, okay, which is nothing but 2.4 communication links. So communication is nothing but cables. Okay. To make a to access the application from one place to other place. Okay, these cables will play very important role. For example, in your data center, we have a data center. Let me open. Just I'm making you no for your uh, for the content to make a note of it. Okay, everything we have documented. I will share this syllabus with you guys as well. And let's try to understand the how the cables were connected in the network. Okay, first of all, assume that this is your data center, one data center, or okay, you can consider this is one of the data center in Bangalore. Okay, so in the data center itself, the most important thing is servers will be used. So why the servers being used to host web application? For example, application could be anything. It depends upon the company product. Okay, if the company offers the e-commerce website, e-commerce product. Okay, if the company offers for internet banking, right? If company can offer any loan related kind of application or services, if the company offer DNS services, everything will be inside of the server itself, right? Let us assume here we have the web application for e-commerce, for example Amazon. Okay, so let us assume we have the two Amazon servers. To log in to the e-commerce website, Okay, there itself they will we can customers can access or clients can access, end users can access the Amazon.com. Once they log in into that application, they can purchase the mobiles or they can do some business related works. Okay, so for that, to make a access from the internet, users will be there in the internet, right? Let me open this. So this is the internet. Okay, users are sitting outside the internet, outside the data center. From here, he will just type www. Okay, so similar way like this. Just it's straightforward. Okay, he will type www.amazon.com. Okay, so I said in the internet. Okay, when I type the www.amazon.com, it's navigating to one of the web application. This is the flow I'm explaining. Okay, so this web application is hosted inside of the two servers. Okay, without any connect, and it will be connected through internet, right? We'll be discussing the networking. We'll be discussing about what is switches, what is hubs, and what is router. That will be discussed later on. Now we need to focus only one thing called cables. On Webcom, we'll be having called network three-layer architecture. For example, we have a router here. We'll be having switches here. Okay, so these switches in each and every server and each and every switches will be having called one of the network important component called NIC, network interface. Okay, in the compute level, we can call it as NIC. In the networking level, we can call it as ports or interfaces. Okay, so just please remember here one of the NIC called here there will be one interface which will be associated to the server NIC. On the switches or networking side, we'll be having called interfaces. It could be 1 gig or 10 gig, or it depends upon the models that we'll be discussing later on. So now we'll be purchasing the cables and we using that cables. Okay, we'll be connecting to the switches like this. Okay, in the similar way, from the second server also will be connected to this switch. So this switch is nothing but access switch. The switches which are directly connected to the computes or the servers are called access switches. In the top of it, we'll be having one more switch called, either it could be distribution switch or the core switch. Okay, so this access switch will be connected to the core switch. Okay, and this core switch will be directly connected to the router, which will be the front end, to the internet. Okay, internet have the direct connectivity to this router. So here, what are the lines which I'm drawing here? Everything which it will be referred to the cables. Okay, so this distribution switch or core switch will be connected to the router. Now let's see how the traffic will flow from the outside inside to outside, outside to inside. Okay, so when any user try to access the one of the web application called Amazon.com. Okay, the traffic will be routed from his mission to the internet, and internet, which is nothing here we can consider as iService providers. Okay, it could be ISPs, service providers. It could be Airtel or BSNL or Geo, whatever service provider. Okay, or SIFI, whatever. It depends upon their company's service provider. Okay, this will be connected to the this end user will be connected to the internet. Internet how to reach this Amazon.com. It knows it is connected to this particular router called customer name called Amazon, and it will be routed the traffic to the Amazon router, and this router will forward the traffic to the distribution switch. Okay, via this interface and via this cable, and this distribution switch will forward the traffic to the access switches, and this access switches will be forward the traffic to the either one of the server. Here, the application team might use the load balancers, or to control the traffic, we can use the firewalls. That's a different platform that we're going to discuss later on. Now, this is the two-layer architecture, three-layer architecture. Just I'm referring here. Okay, this is a normal traffic flow. Okay, then once it is accessed the application, once the request comes from the end user to access the web application, this web application will accept that request, and this will return the traffic back to the access switches, distribution router, and finally reaches the end user. So here, what I'm trying to explain here is, in the networking, there are a lot of components are involved. Service provider is one of the service which they offer to make a connection to the router, and router will have the connection to the distribution switch. It has the cables, and it has switches, and finally reaches the server. If all of a sudden, if one of the application goes down, okay, you as a network administrator or network engineer, your responsibility is to troubleshoot each and every layer, because from the router to your sub application, there are not a lot of devices were involved, a lot of cables, a lot of interfaces were involved. If as this is the hardware, right, we cannot give name of the particular hardware. Anytime any interface can go down. Maybe because of some issues. Any interface, it could be if one of the interface goes down, or here or here or here, anywhere. Okay, the application at the end of the day, application service will goes down, and the customer, they will raise escalations, and you are the point of contact for shooting one by step by step. But from your standpoint, you have to verify each and every cable, the status of the cable switches, routers, and the cable. If the cables are fine and if the interfaces are fine, then we have to say to the customers or your superior stating all the network network interfaces are up and running, so we are good from our network standpoint. Okay, so this is the basic architecture which we will discuss more on it. Okay, any questions from anyone?
Hello, sir. Just you repeat that diagram one more time. You can repeat it. I'm unable to get it. On to the directly to the switches.
No, routers.
Router.
This is the router. Yeah, router will be there. This will be the router. Okay, from the router we'll be having we'll be connecting to the, depends upon the architecture. Okay, in the most of the broad-based companies, they use two-layer architecture or three-layer architecture. If it is two-layer architecture, directly the core switches will be connected to the access switches, which is core switches. Again, we will be having distribution switch and access switches. I'll explain later on what is access switch, why we're using the distribution, why we use the core switches. That's a different story. For now, in order to understand the architecture, just this is the flow. Service providers.
Sir, ports and NIC, what is it is written here? NIC and ports. NIC means what, sir?
Network interface card. It's network interface card, which is nothing but which is nothing but interfaces or ports. I think this is the topic we are discussing. Yeah, if you see network interface card,
Okay, sir.
To connect our computer servers to the network. Here, network it could be switches or routers. Okay. So
Yes,
for
sir.
each and every server or switches or the routers will be dedicatedly assigned a few services, a few ports, few interfaces. In few routers will be calling that interfaces. It is about later on. But for you now from your standpoint, you need to consider network interfaces. NIC will be calling that as in the servers or in the computer. In the switches and the routers, will be calling that as a interface or okay. So this is about communication links. So we'll be using the cables here. Now let's try to understand another important. Yeah, I already read 2.5 service call switches. On local networks, we typically use switches to connect computers, servers to the network. So what is the purpose to make a connection between the two computers to the network or servers to the network? Allows them to communicate with each other. Okay, so this is I'll explain it to what is switches when we discuss, right? At the time I'll discuss about what is L2 switches, what is half duplex, and what is full duplex. Okay, what is L3 switches, and in which situations, what is the STP. Okay, that will be going to discuss later on. Just these are the networking components you need to remember. Okay, on each and every component we're going to discuss with in advanced level. And the next topic is, so next point is 2.6, which is nothing but routers. Here again, okay, routers are used for number of reasons. Okay, the first main reason is to figure out what path to use to get to certain destination. Okay, so one of the use cases, it will figure out what path to be used to get to the certain destination. In this case, so let us assume this is the router. Okay, for example, this router have connection to the two switches. Whenever a user wanted to access the web application called Amazon.com, which is inside of the data center, okay, the traffic will come to the service provider, from service to the router. Router have the two connections to reach the destination. Okay, it can come via this interface and to reach the destination, or it can use this interface directly to access from the access switches to directly to access the web application. So this router will decide what is the best path to use to get a certain destination. Okay, so this is one of the uses in the router. Okay, now the last important component called in the network called 2.7 firewalls. So which is used to control the traffic. Okay. Nowadays, we are seeing a lot of hacking. Okay. A lot of unwanted. Okay. All right. I don't see any comments. Okay. Nowadays, we are seeing a lot of persons are hacking the systems, right? Because one of the reason they can hack the system is they are not managing any proper security devices to control the traffic. Okay, for example, here in this case we don't have any firewalls or security components to restrict the traffic. Let us assume here there is one more end user. Let us assume who is a hacker. Okay, who is a hacker who want to access, who want to hack the system, or who want to bring the service down. Okay, his reason would be anything, right? He wanted to bring the service down. So what he does is, since this application is exposed to the internet, what he does is he will send plenty of requests. Instead of one request, he can use any legacy hacking tools. Okay, or he can build his own code to send n number of requests to the same website. So he will keep on sending the traffic. Like for example, he can send the DNS traffic, he can send web traffic. Okay, continuously will send the traffic to the same web application. He can send millions of requests at the same period of time. So this servers cannot handle millions of services per second. It cannot afford, and it cannot. And the service will get crashed. Okay, to protect this kind of scenarios, every company will ensure to keep the firewalls as a front end. Okay, so let's take the component here called firewall. Here they will keep here, or here or here, anywhere. Okay, so what happens? So here the network teams will this firewall have the two important components. Okay, let me let me make a note here. First one is security policies. The second one is IPS and IDS. Okay, if IPS, what is IPS and IDS will be discussed in the security context when we're discussing. So this service will ensure if the traffic contains if the traffic contains any malware, or if it considers as malicious traffic, it blocks the traffic. Okay, this is one kind of security services which is offered by majority of the firewall products. And come to the security policies. So users, I mean, network administrations has to explicitly define the policy. Like, in this case, let's take an example, right? So in this case, for example, customer is his IP address is 1.1.1.1. Okay, and the IP address of the Amazon is, for example, 2.2.2.2. Just I'm giving example. Okay, so in this case, he has to create this. Okay, he has to create inbound on outbound rules, policies. What is inbound policy? Incoming traffic. So this incoming traffic has consists of source IP, destination IP, protocols, and ports. Okay. So basis on this information itself, he has to create the policy. Okay. to permit the traffic. So he will define the rule. Source is coming from 1.1.1.1 and going to destination 2.2.2, port number 443, port protocol TCP or whatever. Just if the firewalls see this request, one source from 1.1.1.2, 2.2 or port number 443, it will be writing policy to permit the traffic. Okay. For example, here the another customer IP address, another hacker IP address is 2.2.2. Now let me ask you one question, guys. So I have written only one policy to permit the traffic, and explicitly it's going to deny all the remaining traffic. Deny all remaining traffic. So in this case, if the hacker from source IP from 2.2.2 is trying to access, sorry, 3.3.3.3, let me correct it, is trying to access 2.2.2, will the firewall will permit the traffic or deny the traffic? If the if the hacker initiate the traffic from 3.3.3.3 to 2.2.2 on port number 443 TCP. Now here the question here is, will the firewall permit or drop the traffic? Drop the traffic. It will drop the traffic because we have an explicitly rule stating for any product. It could be ACA, it could be firewall, it could be Palo Alto, it could be FortiGate or checkpoint. Whenever we create any inbound policy, explicitly at the end of the policies, it will be defined with a deny statement called deny all remaining traffic. Okay. If you implicitly if you add the policy, then only it will be permitted. If not, remaining traffic will be automatically within. But this will ensure that to control the traffic from unwanted to control the traffic from the unwanted users or hackers. So this is one of the important topic in the security. We'll be discussing more on it. Okay, which is nothing but firewalls. Cisco have ASA firewall. Okay, we'll be having multiple products. Okay, let me explain to you. Cisco has ASA. ASA. Okay, another important product majority of the companies are using is Palo Alto, FortiGate. Okay, checkpoint. I think 1, 2, 3, 4. Yeah, majority of the companies uses either one of them in their company. Okay, which is to control the traffic. So so this is very hectic operation, guys. Remember, managing the security or managing the firewall is not a simple task. Let me tell you one thing. The packages are more high who have good experience in the security. Always the packages of the CDC will be low who are doing in the networking or switches and routers. Remember that point. So companies always give more compensation, more salaries who have the good knowledge on the security, because this is hackers, a lot of unwanted traffic will be introduced into the network. Oh, one more thing, even not from the internet, right? So even not from the internet, even the persons who are sitting in the data center also, they can hack the system, or they can send some unwanted traffic to the system. For all of them, we are using only one endpoint or one platform called security. So this security will be very helpful to control the unwanted traffic. I hope this is very clear to everyone. Any questions? Okay. So looks like this session will end in 10 minutes as it's scheduled for 40 minutes. We need to log in back to the same link again. Okay. So this is about the basics understanding of the network. Now let's try to understand one important no, called OSA layer. Let me remove this new. Save. Okay, OSA layers.